All right, hi everyone. As I said, I'm Karina. I'm going to be talking about how we're going to be encoding secret messages in your barcodes. But I guess the motto of the talk, or the theme, and what you're going to be thinking about throughout this entire talk is, why do I care about barcodes so much? I guess that starts with my background. The last 4 years I was at Warby Parker working on logistics and supply chain work, and basically a week ago I started a new company called Transfix, also working on logistics. So what is logistics? So the way I explain my job to my parents is that I move things from point A to point B. So when I worked at Warby Parker, I basically had a job of getting your glasses to you from across the world, from China, from labs, from warehouses, all to your doorstep. And these glasses can travel in any way, shape, or form just to get to your door. And if you think about it, there's a lot of movement happening across the world as we speak. Freight is moving all over, and the main way all this is happening is through shipping labels. So if you look at these shipping labels, they have a ton of information on them. And you've seen these, you've gotten your Amazon Prime package, and you've inspected it, you're like, yes, that's my name. Yes, it got to me from some warehouse in Idaho. But I guess my main point here is that the words on these shipping labels aren't the most important part. As you can tell, the majority of the real estate on these shipping labels is barcodes, and a variety of barcodes, to say the least. So barcodes can be used by carriers to process your package and to get it from point A to point B. But barcodes aren't only used on shipping labels. They also have, there's a few other kind of barcodes. There's a lot of barcodes, but I'm going to be talking about a few in particular. The Code 39 barcode is also used on shipping labels every so often, but it takes a lot of black and white lines just to output a certain amount of data. So shippers have drawn away from using Code 39. Businesses, however, are using Code 39 to encode valuable information that you don't want your customer experience associate typing by hand. So if you're a retail employee in your store has a barcode scanner already, why not just have them scan this barcode instead of typing in this 12-digit sales order ID? It limits the errors they get, and it's just so much more efficient, so much easier. The UPC barcode is a barcode you've probably all seen and probably ignored. Think back to the most recent book you bought, or the most recent cast iron pan, or even a banana. Think about the banana that you got that says Dole on it, and it has a barcode right on that sticker. And so that barcode is this UPC barcode. And we can dive into that one a little bit more, just because it's so prevalent. So a UPC barcode has a ton of information on it. Just think back to your banana. The first 5 digits on that barcode are the manufacturer that you see. And that basically tells you exactly which warehouse your banana came from. And so that warehouse knows that it can keep track of all of its bananas as it leaves the warehouse. And that item number that follows the warehouse ID is the ID that says this is a banana instead of an apple. So every time you check out at a store, you scan this UPC barcode, and the system's like, yes, it came from this manufacturer. Yes, it's a banana. Let me decrease inventory on this stock, and you may go on your way. But in addition to all the numbers that you see at the bottom, you can tell that at the top, all of the hidden information that it takes to actually power a barcode. There's padding, there's a check digit to allow the scanner to actually scan it. And so you might be thinking, how does anyone use this like hidden encoded information? So to get to that, we can look at a shipping label. This is an actual shipping label I got from Amazon. I have like it here to prove it. And so you can tell there's 3 barcodes on there. The top 2, it's like a QR code, it's a different type of barcode, and they're all 3 different types of barcodes encoding 3 different types of information. But we're gonna focus on the one on the bottom. That's the USPS barcode that USPS, in general, just uses across all packages. So this format is applied everywhere. And so you see that barcode at the bottom, it starts with 9361, and that's what you see. And that's what you get in your email from Amazon, being like, oh, like you should go to Google and put this tracking number and let me track it until it gets to my doorstep. But that's not what the carrier is seeing. The carrier is seeing, once it scans this barcode, once it's leaving the warehouse, is seeing this outrageously long number. And you're just like, well, what do all these digits mean? I only cared about like the 936, which got me my tracking information. So we can take a step back and look at it in detail. So I put a dotted line for what we see, which is on the right, and what we don't see, which is on the left. So 420 is an identifier. So every part of the barcode that has secret information has an identifier saying, what is the secret information going to be? And how can the carrier parse this and do with it what it needs to do? So 420 actually means, look out, a zip code is coming your way. And so the next 5 digits are going to be a zip code. And so 11215 is my actual zip code. So, and this actually came out of the barcode once I scanned it. And so the carriers use this to actually route your package. So say Amazon's in its warehouse packing up your book to get to you. It slaps this shipping label on the box. Someone scans this barcode and they're like, okay, this is going to Brooklyn. It needs to get on like truck A into postal carrier B's bag, and then he can drop it off when he's like walking down that street. And so say someone messed up this barcode and put a zip code of like California. And let me tell you, this has happened in production. And so this package will get to California before anybody realizes that it's not supposed to be there. And you're just like, but like, it says it in clear words that this is going to Brooklyn, New York. Nope, it was not encoded in the barcode, so it made it all the way to California before anyone realized that it didn't belong there. And so, of course, on the right is that long, beautiful tracking number that you all know and love, and we just impatiently stalk, like we all do. But so, how did the scanner actually know how to do this? And when I say scanner, I mean this beautiful barcode scanner, which we'll be using later. How does this barcode scanner function? How does it know to interpret these black and white lines into all of this secret data? So let's take this beautiful barcode. Just, you know, plain ordinary black lines, who knows what's in there. And let's dig down deep into what the scanner does. So step 1, it has to convert the LED light that comes out of it. So when you do, there's a nice red LED light that shines and reads the black and white lines. So what it does is it notices that there are black lines and there are white lines, and it kind of works like a switch. So the black lines are read as 1s and the white lines are read as 0s. And these are interpreted and then they relate back to numbers. So say like 15. You can see that 15 is represented by 1 black line, 1 white line, 3 black lines next to each other, and so on. And so when you see like 3 black lines next to each other, when you're seeing it, it's really just a thicker black line. But so let's go back to our barcode. I pointed out where the 2 characters that I encoded into this barcode are. And, as you can see, there's obviously a lot more black and white lines than I'm pointing to, but that has to do with check digits, padding, like start characters. There's a lot of weird characters that go into barcodes that aren't as important right now. But yeah, so you can see that first red arrow points to 2 black lines, 3 white lines, 1 black line, and so on, and there's your second character. But so, okay, we know that exists there, and what does it mean? So the next step that the barcode scanner has to do before it translates your information is has to make sure the check digit's correct. There's a long calculation that goes into this, basically looks at all the digits and does mod 103 and converts it back and stuff like that, but we'll continue past that. But say your check digit's correct, and that means the barcode scanner realizes that this is a real legit barcode. I'm gonna scan this, it's all gonna work properly. And so now we wanna see what our barcode actually says. We have these 1s and 0s, and that actually means it's the number 40. And what 40 means is that in some barcode encodings, this one happens to be a code 128 barcode, which is the standard USPS barcode, and UPS uses this and everything like that. But so in that encoding, 40 actually translates to a letter, and that letter happens to be H. There's a huge mapping between binary patterns to numbers, and then numbers to ASCII characters, depending on encoding. And so this just happens to be the one for code 128. And so then we can look at the next one, and that actually happens to be just 41, and that happens to be I. So the barcode converted everything, went from black and white lines to 1s and 0s to a number to the actual ASCII text through, and there's a decoder in the barcode scanner that does all this magic for us. And in the end, it just acts like a keyboard. I have it hooked up to my computer right now, and the input's just going to be like a keyboard. So it can even format all the text for us. So when we scan this barcode, all we get is hi. This seems extremely complicated, and it's a lot of black and white lines just to get the message across, but that's what it takes to encode a barcode. But so, this has been 13 minutes of this talk, and I haven't even talked about Python, and we're at PyGotham. So to talk about Python, we have to talk about how these labels are actually printed from a printer. So there's nice fancy shipping label printers that take a specific code, which is called ZPL. And ZPL stands for Zebra Programming Language. And that relates to the Zebra printers that these shipping labels actually print out of. So the last 4 years, I guess the last 2 years at Warby Parker, my job was print these shipping labels for all these individual carriers. And my first step into that was, how do shipping labels work? And how does that relate to me programming? So I looked into it, and I found ZPL, and it looks like this. And I was like, well, I don't actually really want to write that. And my day job is writing Python, so how am I going to fix this? So as you can tell, ZPL is very command-based. It was written originally to be ASCII basic, but yeah, it's just commands on commands, and we can just obfuscate all that away using Python. So let's do it. So I started out, let's write a simple Zebra class that has the init method with our ZPL list. And ZPL is just going to take a bunch of commands that we're going to want to spit out back onto our shipping label. And then a nice clean render command that wraps our shipping label with XA and XZ because that means I'm starting a shipping label and I'm ending a shipping label. And the end user who's writing Python doesn't really need to know this at all. So what's the first thing that we want on our shipping label? We want to write some text. So let's add a text method. So ZPL requires you to do like $FD, whatever, and has to format it the exact right way. But this can really just be a Python call that's like, I want this to live at X coordinate, at Y coordinate, and here's my text that I want to write. So here in the command line, I write, give me a zebra label. I'm going to write some text at X equals 10, Y equals 10. It's basically like a graph. And say, hello, PyGotham. And then when we render it, we get this beautiful ZPL that we really didn't even have to think about that whole time. And so when we draw this label, it kind of looks like that, which isn't that exciting at this point and isn't even legible. So let's make it bigger. So what do? We just make a Python function that increases the font in ZPL. And so font is like, has all these defaults, has all these settings, and the end user doesn't really care about font width. Like, I don't really know how wide my font is. I mean, I don't really care most of the time. But all I know is I want it to be taller. And so I'm just gonna set it to 50, just arbitrary big number. I set font height to 50, add in my text, and render it with my font settings all set up. So what does this look like? So much better and actually legible. But once again, all I care about are barcodes. So let's add a barcode to this. So this is barcode in ZPL. A bunch of arbitrary letters and numbers. And I don't, like, when I first looked at it, I was like, I have no idea what's happening here, and I don't want to think about that. So let's write a Python function to get rid of that. So as you can tell, a lot goes into writing a barcode. But we have all of our default settings for that. So we don't really care about, is there a check digit? Do we like print the tracking number underneath? We just hide all this away by translating our beautiful Python commands into ZPL language and then just return a string back and pop it onto our ZPL list. And so we do it. We create a label, we set the font to 50, we add in some text, and then we add our good old code 128 barcode that we've been using this whole time. We put it a little down. I added some arbitrary tracking number because it doesn't really matter. And then this is the ZPL that gets spit out. And so what does this actually look like? Ta-da! We have a real shipping label from what we built in Python. And it actually works. It like actually prints out. And to prove it, I use the exact same module to print out a completely separate shipping label, which I have here. So you all can see it. So I'm going to switch gears and just switch to text edit so I could use my keyboard for this. So we have our barcode scanner, and we have our barcode, and then we scan it, and boom. Without you realizing it, I encoded the entire word hello in this barcode. And that was all done through just Python and without really having to know how barcodes work at all. So I think that's pretty good and actually helped me a lot in my day job, because when you're sending information to USPS, you have to send them the like account ID, the zip code, and everything like that, just so they can route you your package correctly. So let's go back. So I've been talking about shipping labels and all, and I know it's super applicable to only one industry and happened to be my life for the last 2 years and probably not all of yours. So what else is out there for barcodes? Believe it or not, this is real. A rural village in China decided to build a QR code out of trees in their forest. And if scanned from above, this links to their village's tourist page. And like how they expect people to get that high and to scan it, that's like an exercise left to the user. But it works. It's super cool, and it's a barcode in real life. And another completely opposite thing is barcodes were used to inspire art. There's artists that moved to Utah that now lived among like tall white aspen trees, and all he saw were barcodes. So he decided that he wanted to create some art that demonstrates how nature and technology interact, and he actually won an art prize for this. So I don't know, it's pretty cool. And honestly, barcodes have a Twitter account. Like, they're much cooler than me. They obviously tweet much more often than I do. This wasn't even the most recent one, and this is from a few days ago. So honestly, barcodes are super interesting, and I didn't even realize they existed or impacted my life until I had to work on this random project at work. So here are some takeaways that I think you should take away from barcodes. There's a lot hidden in plain sight. You're getting your Amazon package, and a lot can be passed under your nose without you even realizing it. So I say download like a barcode scanner app on your phone and just get interested and see what they have on there. Because any old barcode scanner works on like all of these barcodes. Like I bought this off Amazon for like $5, so it's easy for anyone to do. And honestly, why is anyone typing anything when you can just scan the barcode? There were so many instances in retail stores that I watched some people like work one day, and they were just like typing. They like couldn't see the like sales order number. I was like, why are you doing any of this? You have a barcode scanner. Let's build you a barcode where you can't accidentally mess up this sales order ID and like impact a customer. Like, always scan it instead of typing it. Like, I think that's my new motto. But yeah, this is how I feel about barcodes, so I hope you enjoyed my little rant. Yeah.
How much information can you fit in a 2D QR barcode?
So it's 2D QR barcode, which I didn't really talk about that much. The main difference from a QR code from what I was talking about, which was a 1D barcode, is that a 2D barcode has a lot of room for error. So part of the QR code cannot be shown at all, and it can still be scanned. So it can hold a lot of information and still be resistant to like wear and tear. Whereas if like this barcode is kind of sort of scratched off, or is like something's a little blurry, it doesn't scan. So like a QR code is always like much more clear, much more like defiant to wear and tear, and can hold a lot of information. I don't know the exact amount, but can hold a lot. And like different barcodes can hold different amount of information. Like code 39, which I showed earlier, takes a lot of black and white lines just to display a small amount of data, whereas code 128 can display a ton of data in like half as much black and white lines. So really the encoding is what determines how much data can actually be stored.
I noticed I forget which code it was, but one of them had, when you were coding high, there was 11 bits per letter. That seemed like, are there 3 check digits, or do you know anything about that choice?
So I forgot to mention this, but so each number maps to the digits, and so the way it's structured is that each number maps to 3 sections of black and white lines. So I don't know why it's exactly 11. I am answering your question. I don't know exactly why it's 11, but it is formulated so there will always be 3 sections of black lines and 3 sections of white lines. And the max number of like lines next to each other is 4. So you can always have like 4 black lines next to each other and then like 1, 1, 1, 1. But I don't know exactly why it's 11. It's a prime, yeah, I mean, prime numbers are always cool. Anything else? Cool, thanks a lot, guys.